Good day, we are second year civil engineering student from UTM. Today we are going to present our open-ended experiment which involves shear force and bending moment. We are from group 20 and our member consists of YEOW, XIAN, and me, Ting. Without further ado, let's get into the introduction and objective of this experiment. Shear force at any point along the beam is defined as the force that tends to produce a sliding barrier on material along a plane that is parallel to the direction of the force. Whereas the bending moment is the moment included in a structural element such as beam when an external force or moment is applied to the element causing the element to bend. The objective of this experiment is to study the shear force and bending moment at the particular section as a section and compare it with the theoretical calculation. This is the content for our video, which consists is part of our demo lab video and will be presented by each of our members.
Alright guys, so today we are talking about the shear force variation at cut section due to the variation of load and also load position experiment. So first, the load P is placed at the location between point B and also point A. Alright, so after that, the value of shear force at point B, right? Point B is also known as section XX, is measured. After that, the load is replaced by 200 grams of loads and also 300 grams of loads. And the same thing, the shear force is recorded at the point B. So after that, the load is the 100 gram load is moved to point here. Is moved to the point between BD and also the point between B. Right, you can move here and also there. So after moving to these two respective points, the shear force is recorded at point B, and after that the load is replaced by 200 grams and also 300 grams, and the same thing, the shear force is recorded at B also. So after all, the graph of shear force at section XX against load P and graph of shear force at section XX against location of load P from point A are plotted. And that's all from me.
By using the measured shear forces from the previous part, a shear force diagram is drawn for all three cases. The measured shear force at position XX was also obtained from the shear force diagram and is then compared with the measured value.
Shear force due to uniform distributing loading. Three identical point loads are applied where each load consists of the same magnitude. All these loads must be applied next to each other and make sure the distance of this load is the same to one another. Then, the uniform load W is calculated by using the formula total load applied divided by total distance. The value of shear force at section XX is calculated by, firstly, we need to obtain the reaction RB by using this formula. Next, we can calculate the shear force at section XX by using this formula. Lastly, the calculated value of shear force is compared with the measured shear force at section XX. Bending moment due to uniform distributing loading. Two identical point loads are applied where each load consists of the same magnitude. All these loads must be applied next to each other and make sure the distance of this load is the same to one another. Then, the uniform load is calculated by using the formula total load applied divided by total distance. Then, the value of bending moment at section XX is calculated. Next, the calculated value of bending moment is compared with the measured bending moment at section XX.
Positive and negative bending moment. So the load is located in between point A and B. The bending moment at section XX will become a negative bending moment, which is also known as the hogging moment. So when the load is located in between point B and D, the bending moment at section XX will become a positive bending moment, which is also known as the sagging moment. This is the same for the case where the loading is located in between point D and C. The bending moment at section XX will also become a positive bending moment, which is also known as the sagging moment. So in the next part of the experiment, the main objective is to get the bending moment diagram where the maximum sagging moment and maximum hogging moment are having equal absolute values. So the distance d in this experiment is the distance between B and P, and very important, the distance d should be in between 300 and 440 mm. We can use any value of load W and distance d, which must in between 300 and 440 mm. Substitute both of them into the equation and we can obtain the load P required to ensure the bending moment of the maximum hogging and maximum sagging are having equal absolute values. After this, we can draw the shear force diagram and bending moment diagram to obtain the bending moment. After we draw the diagram, we can validate that the maximum sagging moment and maximum hogging moment are having equal absolute values.
Alright, this is the demo experiment for point of contraflexure of B. What is contraflexure? Contraflexure is the point which the bending moment is equal to 0. Okay, so this is the experiment layout. We have the log W and the log P. Okay, so log W we need to assume ourselves, and then the log P we can calculate by using the formula, and this is the formula. So from A to B, the B is the pin support. Okay, they have their distance of 140 mm. And from point B to point D, the sectional XX is the cutting, so we have 300 mm. And from point D to point C, we have 140 mm. And from this log P to the C, we have the distance of D, and this value D must be between 0 and 140 mm. Okay, so after calculating and getting all the data we need, so we can now plot the shear force diagram and bending moment diagram. So after plotting the bending moment diagram, we can prove that at this point D, the cutting here, the bending moment will equal to 0.
Next is the experiment for proof of superposition principle of shear force and bending moment. So, firstly, we obtain the measured and calculated bending moment and shear force at point D, which is the section of XX for these three figures. So, the first one is where the load is between A and B. So the second one is 1/3 from point B, and for case 3, the point is at the load is at about 2/3 from point B. So next, we calculate the shear force at point D for 3 cases, and the bending moment at point D. According to the superposition principles for bending moment and shear force, the summation of the bending moment and shear force that we have calculated before is equal to the moment and the shear force according to the diagram of figure 4, which is the position of the load combined for the 3 cases in one diagram. Thus, we can prove the superposition principle for both bending moment and shear force.